when we talk about movement, we cannot dissociate it from time. It's just that, if there wasn't any time interval separating the two positions of a particle, it wouldn't be possible to measure movement of any kind. Coincidentally, our memory also depends on time. If we couldn't remember objects, they would cease to exist, even if they're still around. The most important thing, in this case, is to note that the assertion of physics that vacuum energy would drive the acceleration of the expansionary universe would turn into an interpretive error. This is due to the fact that it is already amply demonstrated that the vacuum energy, if it existed, would be negative. Think of space as acting like a spring. If this space were stretched, it would generate tension between its ends, with the force pointing in the opposite direction to its stretching. That is, when curved negatively, space would give rise to the emergence of a vacuum, or a void of information. It is that, according to the theory of relativity, space and time are complementary to each other. If space stretched, a contraction of time would be expected. As in the absence of time there is no movement that can be measured, the apparent void of information linked to the vacuum is understandable. It is said that the expansion would transiently erase the information, which would allow us to describe the stretching of space directly. Bearing in mind that the information would remain there without being able to be accessed directly, the expansion would always present itself to us with a delay, or as an image that would have been projected in our past. The villain seems to be cosmic radiation, which would act as a kind of messenger replaced in space in the function of communicating cosmological events. As for the time retained in the translation process, one can only make assumptions about its existence in a vacuum without practical demonstration. By creating these seemingly empty regions, space would be generating inertia and retaining light, transforming it into dark energy. As for the space messenger, here would be established what would be the first phase of its harmonic movement. Radiation tells us that space, when stretched, would promote an increase in elastic potential energy. As would happen when you stretch a spring, the force would point in the opposite direction of its stretching. This should be accompanied by a slowdown in the movement of galaxies, as more space is being created by dark energy. This is not what you see in the practice of Doppler. The aforementioned effect stems from considering that light and space would be one and the same thing, disregarding the timeless quantization of electromagnetic radiation, manifested in the uncertainty of the position or speed of light sources. Briefly, it can be said that the before and after of the scattering of the light of stars together with each one of us would have mixed together the final effects of the different phases of the simple harmonic movement. That is, the generation of spaces by dark energy would have incorporated the acceleration of the movement of galaxies only in a phase after the radiation packing. The contraction of the spring of space, accompanied by the acceleration of movement, would be exposing its own expansion in a way that is left in time. It should be noted that to allow the recording of the expansion in a lagged way, it would have been necessary for there to have been an inversion in the direction of the arrow of time, followed by its dilation. Before that, time would have been in contraction. The transient retention of information suggests that this arrow would have pointed, at some moment, to our future. The inversion of the arrow would be a justification for the dilation of time, thus allowing the observer to rely on his memory. The disappearance of the first phase of the harmonic movement of light would have made the two phases continuous, due to a principle of exclusion of direct access to one of them. As one could not have direct access to the resting phase of space, as it is timeless, the phases of its expansion and contraction would have become continuous and mutually exclusive. When these movements were described with delay by cosmic radiation, the tendency of expansion and contraction of space would have been suspended in the direction of infinity. If the dark energy was imperceptibly creating spaces, directly pushing galaxies apart, the limited speed of light, which we use to track the event, would have to tell us that the spaces would have been created at a moment before the reversal of the arrow of time, or before the Big Bang. However, as there's only what can be remembered, we tend to conclude that these spaces would have remained in our past, and that the light would, necessarily, be coming from there. Finally, in this alternative view, based on delayed access to information made available by electromagnetic radiation, we would be forced to reevaluate the concept of dark energy acting in an absolute way in the past. If we can't directly measure time in the future, there's also no way we can describe any kind of movement in the direction of its arrow. The movement can only be measured when the dissociation between matter and energy is already complete, an effect that would accompany the continuous scattering of light photons close to the observer. It may be that only light, occupying a narrow band of Maxwell's spectrum, was directly visible post-Big Bang, but the information contained in all bands of that spectrum became potentially accessible to remote tracking when the jet of matter would have projected into the past. There could not be, in this case, a dark energy acting directly in space-time, because all energy is linked to some kind of movement. Therefore, if we could detect this energy in motion, it would cease to be dark. The continuous movement between the galaxies, which we register by the light in a time-delayed way, is what allows us to conclude that dark matter exists.